Okay, for geometry honors for the test review, we're going to start with information out of section 10.1. Some of the stuff you guys covered in there was arc length, area of a sector, and area of a segment. The formulas are going to be clearer on your sheet than what they are on video. Okay, but basically for arc length, we have two different formulas, one if it was given in degrees and one if it was given in radians. So the arc length, they use the variable s, and they said n over 360 times 2 pi r. Remember, this part is your circumference, and this part is the fraction, right? The fraction of the whole circle. So whatever degrees over 360 tells you the fraction of the circle. When it's given in radians, your formula is s is equal to theta times the radius. Okay, the theta is in radians. So that's the difference between the two. Okay, for area of the sector, it's a fraction of the circle. So the pi r squared is the area of the whole circle. For area of the segment, segment was sector minus triangle, because you basically have this sector, which is like a piece of the pie, and you're cutting out the triangle to find the shaded part that would be left over. Okay, so we're going to do some practice problems relating to these concepts and the other concepts that were in 10.1. One of the other things that was in 10.1 was the value for central angles and their intercepted arcs. The central angles are the same as their intercepted arcs. So like this angle of 130 would mean that this arc out here is 130. This angle of 40 degrees means that this arc is 40 degrees because those are central angles. They come from with their vertex on the center of the circle. Since this arc and this arc have congruency marks, we know that this arc would be 40 degrees, so that angle is 40 degrees. This arc is marked as 90, so this angle is 90. Now we only have two pieces missing from our circle. Those two pieces relate to these two angles, which are marked congruent. Since the whole circle is 360 degrees, if we add up what we know, take it away from 360, we'll be left with these two parts. Okay, so we're going to do that first. We're going to take the 130, the 40, the 40, and the 90 and add those together. 130, 40, 40, 90 gives us a total of 300 degrees. So I know 300, I take that away from 360 to get 60 degrees left over. I'm going to split that equally because there's two parts that are congruent. So this is going to be 30 and this is going to be 30. Now I can go back and answer all my questions. I have angle PVQ. PVQ, the angle and the arc would be the same. So that's going to be 30 degrees, which is going to be the same as arc PQ. Angle QVS, QVS means I'm going to have to add these two together, so I get 80 degrees. And then arc UT is 30 degrees. And then major arc PST, so I start at P, I pass through S, and I end at T. Remember, that helps you decide which direction you're going, that middle letter there. So PST tells me I need to add up 30, 40, 40, and 90 to see what I would get going that far around the circle. So I'm going to get 200 degrees if I add all those up. All right, next it says, what is the area of the shaded region? And it says the sector. Round the answer 2 decimal places. So this is marked with 73 degrees. That 73 degrees is from here to here. That's not the shaded part. I need the shaded part. So I need to know how many degrees is it over here. So in order to do that, I'm going to take the 73 away from the 360 because every circle is 360 degrees. So I get it's 287 degrees. I'm going to use that in my formula. My formula says area is equal to the number of degrees over 360 times pi times the radius squared. Now this says round to 2 decimal places. That tells me instead of leaving it in terms of pi, I'm going to use 3.14. So I'm going to write that out, 287 over 360 times 3.14. times 32 squared. I can type that all in my calculator as is, depending on what type of calculator you are using. Or you can take it piece by piece and break it down. On this particular calculator, I can type it all in. So I'm going to put my fraction in parentheses. Here we go. 287 divided by 360 is my fraction, times 3.14 times 32 to the second power. Multiply it all together. It says round to 2 decimal places. So on my calculator, I look at my third place after my decimal. It's a 6. That tells me I'm going to have to round up. So it's going to be 2,563.53, sorry, 2,563.36. And there were no units given, so we would just write units squared because it's area, so we know it has to be a unit squared. All right, number 3. 3 and 4 are converting. And when I'm converting from radians to degrees, I'm going to take my radians and I'm going to multiply by 180 over pi. Okay, when I multiply like that, my pi's cancel out. So I'm multiplying 3 times 180 divided by 4. And you can do that in your calculator. You do 3 times 180, you get 540. Divide your answer by 4. There's still degrees in here, right? I get 135 degrees. Okay, for the second one, I have 5 pi over 6 radians. So I'm going to go 5 pi over 6 times 180 degrees over pi. My pi's cancel out. So I've got 5 times 180 over 6. I can do all that in my calculator, and I get 150 degrees. Now, when I go the other way, convert to radians. So I'm starting in degrees and going to radians. I'm going to multiply by the reciprocal of this. So it's going to be pi over 180. Because when you are trying to get 2 degrees into the degrees, you want your pi's to cancel out. When you're trying to get into the radians, you want pi to be in your answer. So you know you want pi in this half. So 30 degrees times pi over 180 degrees, our degrees would cancel out. So the degrees are gone. So now I have 30 pi over 180, and I would need to simplify my fraction. I could divide both by 10, so that gets rid of my zeros, and I have 3 over 18. 3 over 18 simplifies to 1 over 6. I don't have to write the 1, I can just write pi over 6. If you wrote the 1, it's totally fine. 1 pi over 6, that means the same thing. Okay, for 240 degrees times pi over 180 degrees, the degrees cancel. I have 240 pi over 180. I could cancel out by dividing by 10, get rid of the zeros. 24 and 18 are both divisible by 6, so I could simplify 4 pi over 3 for my radian. Number 5, what is the area of the shaded region? And that shaded region there is a segment. So for the segment, we said we do the sector minus the triangle. So a couple things with this question. This is labeled as 3 pi over 2, okay? But this is also labeled with a 90-degree box. So I know this is a 90-degree angle. So then that tells me that this is my base and this is my height of my triangle. Since they're both a radius, then they're going to be the same. They're both going to be 6. Okay, so let's do the area of our sector first. Our sector for the shaded region has degrees of 90 times pi. Says leave our answer in terms of pi, so we'll leave the pi there. Pi r squared. So I've got 1/4 of pi times 36, and that would break down to 9 pi. If you wanted to multiply across the top and then divide by 360 at the end, you're still going to end up with 9. Okay, the triangle. Triangle is 1/2 of base times height. So 1/2 of 6 times 6. So 1/2 of 36 is 18. So how do you write your final answer? It's sector minus triangle. So 9 pi minus 18, and we would say units squared. Okay, so now we have what's the length of AB. We talked about two formulas to use for arc length. It says leave your answer in terms of pi, and your angle is given in radians. So that tells me I'm going to use the formula S is equal to theta times radius. So I'm going to plug in my theta, which is 3 pi over 4, and my radius is 9. So when I multiply across the top, I have 27 pi. When I multiply across the bottom, I have 4. Because remember, there's like a 1 down here. So this would be my final answer, 27 pi over 4. I do not have to simplify that because 27 and 4 don't have any common factors besides 1. And last one on this page, if the radius of the circle is 7 meters, what is the length of GF round to 2 decimal places? Well, if you notice on your diagram, which you can see clearer on your paper, because the video is not as clear, this says 32 degrees. Since I'm using degrees, I know I'm going to use the formula that looks like this. Round to 2 decimal places tells me I'm going to use 3.14 for pi. So I'm going to fill everything in I can. 32 over 360 times 2 times 3.14 times the radius, which they gave us, was 7. So I'm going to multiply everything together in my calculator, and I can do that. Again, you can do it depending on the type of calculator that you have in one step, but you might need a couple steps if you have a more basic calculator. It says to round to 2 decimal places. So what I round to 2 decimal places, my final answer is going to be 3.91. All right, moving on to the next section, 10.2. 10.2 was a lot shorter. There wasn't as much information in 10.2. 10.2 was mostly about the tangents, and tangent, remember, is the segment or a line that touches the circle at one point and the rest of it remains outside the circle. Okay, the important fact was that a radius and a tangent that are perpendicular to each other. Perpendicular means makes the right angle. And then the other part with the tangent is if tangents start from the same point outside the circle, then they're congruent to each other. So in this case, AB is congruent to AC. So we're going to use those facts to help us answer these questions. In the diagram below, CD and ED are tangent to circle F, and measure of CDE is 28. What is the value of X? So we just said tangent and a radius are perpendicular, so we know those are 90. This figure here is a quadrilateral. You guys learned all quadrilaterals have 360 degrees. So if I add up all the angles in a quadrilateral, I should get 360. So I'm going to add up what I know, the 90, 90, and 28 to give me the 208. And then I subtract that from 360, and I'm left with 152. Okay, so X is 152 degrees. Number 2, in the diagram below, LH is 30, LS is 16. What is the length of SH? So I know that this has to be a right angle. So that means this is a right triangle. LHS is a right triangle. We learned that right triangles can be solved by using Pythagorean theorem. So we'll set that up. The hypotenuse is the X that we don't know. The legs are the 16 and the 30. So I'm going to evaluate 256 and 900. I add them together to get 1156. And then I take the square root of 1156 to get that X is equal to 34. Okay, so the whole thing is 34. If this question just asks from like here to here instead, we know this much is 16, so then this would have to be 18. It didn't ask that in this particular question, but I'm just saying if it did, then you would have to use what you know, that the radius is 16, so the rest would have to be 18. All right, number 13, we've got a bunch of tangents. All of these segments are tangents. AC is 12, so from here to here is 12. CD is 5, EF is 4, GH is 3. What is the perimeter all the way around this quadrilateral? So we need to use what we know about tangents. If tangents start at the same point, they're congruent. So GH has to be congruent to GF. EF has to be congruent to DE. CD has to be congruent to CB. If this whole length AC is 12, then that would mean AB has to be 7, since these two pieces would have to add to 12. And then you figure out AH has 7. So now you're adding up all the sides. This side is 12, this side is 9, this side is 7, and this side is 10. So perimeter, we're just adding up all the sides. All right, so we've got 10 plus 12 plus 9 plus 7 to give us a total of 38. Okay, and then the last section, 10.3. Again, there's a lot of information there in 10.3. 10.3 was about chords, and we learned a bunch of important facts. We learned that if we have central angles that are congruent, that these chords would be congruent, and then these arcs they intersect would be congruent to each other, so these arcs are going to be the same. We learned that if chords are the same length, that the arcs they intersect are the same length. We learned that if chords are the same distance from the center of the circle, then the chords are going to be the same length as each other. So this chord from DC to AB would be the same. Okay, we also learned that if you have a diameter cutting through a chord, that it is going to be perpendicular, or if it is perpendicular, it cuts the chord in half. Okay, and same thing, if it's a perpendicular bisector, then it's a diameter. Okay, now we're going to do a couple practice questions with this. We have this information given to us. It's labeled on our diagram, and we see that it says they're perpendicular, so there's a right angle box. What's the length of XW and the length of ZW? So we got two things to figure out. Since this segment is perpendicular to this chord, that means this chord is cut in half. So if XY is 20, then WX is 20. So XW would equal 20. That answers this part. Okay, now ZW, this part, this is we're gonna have to use Pythagorean theorem to solve that. So C squared is equal to 15 squared plus 20 squared. So 225 plus 400 gives us 625. So C is equal to 25. So ZW is 25. So we've answered both questions. All right, measurements are given below. We need to find PR and SQ. So based on what we know, see how this little segment coming from the center is perpendicular to the chord? That's telling us that both of these pieces are going to be 24. Since these chords, PQ and PR, are the same distance from point S, they're both 7 units, then I know that the chords are the same length. So if PQ is a total of 48, PR has to be a total of 48. So PR is going to equal 48. That answers one question. SQ is not drawn in. We have to draw it in. Creates a little right triangle. So we're going to have to call this C and do our Pythagorean theorem. C squared is equal to 7 squared plus 24 squared. So 49 plus 576 gives us 625. And then C is going to be 25. So SQ will equal 25. That answers that question. Now we have to look at the arcs. It says arc PQ is 140 degrees. What are arc PR and arc QR? Well, if PQ and PR are the same length, then these arcs that are intercepted have to be the same size. So arc PR is also going to be 140 degrees. QR is just what's left, because if I know this is 140 and I know this is 140, this is just what's left off of 360 after I add these two together. These two would add up to 280. So if I do 360 minus 280, I have 80 degrees left. So this has to be 80. So the measure of QR is going to be 80 degrees. Okay, so I've done all of my questions. Number 3, name the congruent chords, name the congruent arcs. So our congruent chords are marked here. JK is congruent to ML. Oops, JK is congruent to ML. Name the congruent arcs. So the arcs that are intercepted by the chords have to be the same. So arc JK is congruent to arc ML. And then name the congruent angles. Well, these central angles would have to be the same also. So angle KAJ would have to be congruent to angle LAM. All right, and then you can watch video 2 to see the rest of the answers.